Hi, today I am going to discuss about gyroscope. What is gyroscope? Gyroscope is actually a spinning disc like this. This is a gyroscope. This yellow color shows a disc which is rotating in one axis. So this is one axis. Okay. So gyroscope is actually a measuring. It's a device for measuring, maintaining the orientation based on principle of angular momentum. And gyroscope is a spinning wheel or disc in which the axis is free to assume any orientation. So this is the disc. So placed inside some axis. Okay, and this part is called gimbal. Then this is corresponding frame. This can rotate in any direction. Then if the axis of spinning of a rotating body, if the axis of spinning of a rotating body is given an angular motion about an axis perpendicular to the axis of spin, an angular acceleration acts on the body about third perpendicular axis. What it means? Here we have a disk rotating with this axis, rotating about this axis. Okay. So if we are giving an angular momentum about an axis perpendicular to this axis of spin, so if you are giving an angular motion in a direction perpendicular to this axis of motion like this, okay, an angular acceleration acts on the body about a third perpendicular axis, which is perpendicular to our plane of this paper or this screen. About this perpendicular to this plane of screen, an angular acceleration acts on the body. Okay, then the torque required to produce this acceleration is called active gyroscopic torque. So what we are giving here is a torque. That torque is called active gyroscopic torque, and the effect produced by reactive gyroscopic couple is called gyroscopic effect. So this is gyroscopic torque, and the reaction is called gyroscopic effect. An example: when aeroplane, ship, automobile with rotating parts taking turn, some effects are acting on these aeroplane, ship, and automobiles. Okay, that effects are called gyroscopic. That effect is gyroscopic effect. Then angular velocity. Angular velocity, here we are considering a disk rotating with omega angular velocity. If you are looking from here and you are looking from here, from this end A, then how we will represent this velocity vector, angular velocity vector. Angular velocity vector magnitude is equal to length of the vector. So here, this is the representation of angular velocity vector AB. Length is equal to, length of this vector is equal to magnitude of this angular velocity omega. Then what is the direction? Direction of axis of rotor is equal to vector parallel to the axis of rotor or normal to the plane of angular velocity. Meaning, this direction, this line is parallel with axis of this rotor. Okay, this line, vector line, is parallel with axis of this rotor. Then sense of the rotor. Here, for getting the sense, here it is directed from A to B. Okay, here there is one arrow. For getting that sense, here we use right hand screw rule. If screw is rotated in clockwise direction, it goes away from observer. This you have already studied. Right hand screw rule is the governing rule. Here, if you are looking from end A, considering that the disk is rotating in clockwise direction, okay, this omega, this solid arrow line representing direction of rotation of disk first. So it is rotating with some angular velocity and some constant angular velocity. Here, AB represents its vector. Then it is parallel with axis. So second thing is it is parallel with this axis. Okay, length is equal to magnitude of this omega. Second, this axis and this line both are parallel. Then third, direction. Direction is represented. Direction we will get from right hand screw rule. So as the screw is rotated in clockwise direction, it goes away from observer. Okay, so it is directed from A to B. Here and A, here and B. Okay, and if this disk is rotating in counterclockwise direction, what will have? Here, A is at this position, B is at this position, And we are considering that observer is standing here at end A, looking towards this disk, and the disk is rotating in counterclockwise direction or anti-clockwise direction. Okay, so by right-hand screw rule, if the screw is rotating in anti-clockwise direction, it will come towards the observer. Okay, so here we have to draw one line. Okay, one solid line. Then it is parallel with this axis. Should be parallel with this axis. Length should be equal to magnitude of this omega. Then direction. Here observer is standing at point A, so this arrow is coming towards point A. Okay, so this is how we will represent angular velocity as a vector. So example, air rotor in clockwise direction from end A. So this is example from end A. The direction is from A to B. Okay, from A to B by screw right hand screw rule. Okay, here this is rotating in clockwise direction. So this is a vector and is directed from A towards B. Okay. Then we have to consider another case. Here, similar disk is rotating here. It is rotating in counterclockwise direction. If you are looking from here, okay. So this is the axis of the disk. At the same time, it is rotating about this entire axis plus this disk is rotating about OY axis. Okay, so in this plane, this is rotating. So it is represented after a small time. It is represented as d theta. Okay, so this will rotate like this about OY axis. Okay, this is rotating like this, about OY axis, Then d theta by dt is the angular velocity of axis of spin. This axis, this entire axis plus this disk is rotating. Okay, so d theta by d theta is the angle made by this entire thing, this axis and this disk after some time. Axis of spin about an axis perpendicular to the plane which the axis of spin is going to rotate. So about this axis, it is taking this angle or this movement. This angular velocity is known as angular velocity of precision. Okay, this entire disk axis is changing with respect to another axis. This angular velocity, the angular velocity made by this disk with about this axis OY is called angular velocity of precision. Okay, and axis about which the axis of spin is to turn is called axis of precision. Okay, angular velocity of precision and axis of precision. So here, but which one is axis of precision? OY is the axis of precision. About OY, it is going to turn. Okay, so OY is axis of precision, and angular velocity of the disk changes in direction, constant in magnitude. Then angular acceleration is given by alpha z is equal to omega p. This is the angular acceleration. Okay, this here disk is rotating with some constant angular velocity omega about this OX axis, and same time this entire axis and the disk is changing its position about OY line. So angular acceleration is given by alpha z is equal to omega p, where omega p is d theta by dt. Okay, what is omega p? D theta by dt, precision. Okay, that angular velocity of precision is omega p, and this alpha c is known as angular gyroscopy. Alpha c is known as gyroscopy acceleration. So here we have this disk. Consider disk spinning with angular velocity omega radians per second about axis of spin OX. So axis of spin is OX in anticlockwise direction when seen from front. When you are seeing from front, this is rotating in anticlockwise direction. Okay. Then since the plane in which the disk is rotating is parallel to plane YOZ, here we can see this YOZ plane. YOZ plane. So this is YOZ plane, and about this plane, that disk plane is parallel with this plane. So this plane is called plane of spin. Okay. plane of this disk and this plane, both are parallel. So this plane YOZ plane is called plane of spinning. And in other words, axis spin is said to be rotating about axis OY. The axis spin is said to be rotating about axis OY at an angle velocity omega p. So this entire disk is rotating with about OY. Okay, at an angle velocity omega p radians per second. So it is rotating in this direction with omega p radians per second. This horizontal plane XOZ. So X is this here, O is Z. Okay. So here in this plane, the precession is happening. So this plane is called plane of precession, and OY is called axis of precession. About OY, this entire disk, and this axis is going to rotate about or on this plane XOZ plane. Okay, so precession is happening here. So this plane is called plane of precession.